Kreyo, that we want in slideshow in a presentation mode.
I can see, ma'am.
But then you may not have shared your entire screen. You may have shared or your this window only. Do not share a window. Share your entire screen, then only we can see the presentation mode. Otherwise, you only will be looking for.
Okay, ma'am.
Kirtan, Meissner's effect na સરસ videos bhi available છે હા.
હા મેમ પણ ટાઈમ તમે કીધેલું ને આજે
શોધી કાઢજો હા.
હા એટલે પછી મેં ઇન્ક્લુડ નહીં કર્યું.
એટલે અહીંયા હા મેં
Ma'am, are you able to see?
ha. Now we are also able to. You may start it.
Okay.
All the best.
Thank you, ma'am. My name is Kreyo Kezo, a student of Mechanical Department, and today I'll be giving the presentation. I thank our madam for giving me this opportunity, from which I've. So to start with this presentation, that introduce the topics I'll be going through today, which is taken from the chapter materials of the physics textbook. I'll be of superconductors, namely the isotopic effect. Let's first start. To know the isotopic effect, we need important terms. First, we have the isotope. So what is an isotope? As seen in the slide, species of atoms of elements having the same number of electrons. We also know that the number of proton is same as the atomic number. So it is also defined as same species of atoms of elements having same atomic number but different mass number. As seen in the example, we have mercury, whose isotopes are mercury 200, mercury 201, mercury 202, etc. Or carbon, whose isotopes are carbon 12, carbon 13, carbon 14, etc. As seen in the figure, we have carbon 12, carbon 13, and carbon 14. Here are the numbers 12, 13, and 14. They are the we have critical temperature. So critical temperature is the temperature at which a system undergoes a phase transition from normal resistance to a superconducting state. A superconducting state is a state where the resistance is zero. One thing to be noted here is that isotopes with different isotopic mass have different critical temperatures. Now we have the isotopic mass. All the isotopes of an element have same atomic number on atomic mass. This part is the isotopic. Now coming to the isotopic effect. Isotopic effect is used to show the variation of the critical temperature with the isotopic mass of the ions of the superconductor. We find that the critical temperature is proportional to m minus 1 divided by 2, where m is the isotopic mass. Here Tc is the representation of the critical temperature, and m is the isotopic mass. From the definition, we come to know that higher the isotopic mass, less will be the critical temperature, and less the isotopic mass, more will be the critical temperature. Let us see an example of the isotopic effect. So from this diagram, we can clearly see that increase in the isotopic mass leads to decrease in critical temperature, and decrease in the critical mass, decrease in the isotopic mass leads to increase in critical temperature. Let us first look at the position A. Here at the position A, when the isotopic mass is 204, the critical temperature is 4.12. Whereas if we look at D, it shows that when the isotopic mass is 200, the critical temperature is 4.16. So clearly the difference between them shows that the increase in isotopic mass leads to decrease in critical temperature, and decrease in isotopic mass leads to increase in critical temperature. This particular pattern is also observed in position B and C. So from the critical temperature and isotopic mass, we come to know that shown that these interactions are largely involved in superconductor. Now we have the pressure effect. The structure of the atoms in a superconductor is distorted when an external pressure is applied to a superconductor. So the distortion of the atomic structure is directly proportional to the critical temperature. More distortion of the atomic structure leads to distortion of the electrons, and thus, to achieve a superconducting state, where the resistance is zero, the critical temperature is increased. We have an example, a simple example, for a general example for easy understanding. Here at position A, when the pressure is 1, the is 100. Position B, when the pressure is 2, the critical temperature is 300. So from this example, we can see that increase in the pressure leads to increase in the critical temperature, and decrease in the pressure leads to decrease in critical temperature. This is all for the isotopic effect and pressure effect. Thank you. Hello?
Yes,
You're
yes.
audible.
This is all, ma'am.
મેમ નથી હું તો
હોલ્ડ પર છે ફોન હશે
ના
Kreyo, am I audible?
Yes, ma'am.
યસ મેમ
Continue, continue.
Ma'am.
No, actually, is that done? Because in between I have got a call. So,
યસ મેમ હી ઇઝ ડન
okay. Kreyo, can I have the last graph? Can you explain the last graph again? That was regarding pressure. Yes.
When the pressure is 1, the temperature is given as 200. And when the critical temperature is given as 300. So from this, you can see that increase in the pressure, increase in the critical temperature also. Whereas the decrease also leads to decrease in the critical temperature. Hello?
Okay, so this is, I just wanted you to verify that when do we increase the pressure, it's a critical temperature increases or decreases?
It
Once again you go through, not just now. Once the lecture will be over, when we apply a pressure, what happens to critical temperature? That goes down or goes up?
Ma'am, I think it goes up when the pressure.
But that, if as far as I know, it should go down.
Ma'am, in
That
the
is what
textbook
I
is
feel,
written.
but maybe the other thing that might be, it might differ for another material. If it is so that for different materials the effect is different, or it is a common effect that when we, what I have heard or read is when we apply a pressure, its a critical temperature goes down.
Mm. In the textbook, it's written increase in pressure, increase in the transition temperature.
Hmm. It goes up. Correct, correct. Probably might goes up. I'll just go through some examples and then I'll convey the exact thing.
Okay, ma'am.
See, okay. Kreyo has explained it. Kreyo, very first thing I just would like to tell you that very nice PPTs you have prepared and the color combination you have taken very limited, two or three colors are there. And those also very greatly visible colors, blue, green, red, black, all. So the PPT is very nice.
Thank you, ma'am.
And one more thing you can improve with your PPT is that your PPT number 5, 8, all these PPTs are having so much of theoretical things. If you will see long sentences you have formed, no? Instead of that,
Yes,
always
ma'am.
keep a habit to note down the points on the PPT and then you explain.
Okay, ma'am.
Okay, so this is from my side to Kreyo. As Kreyo has said that for a pressure, another thing I would like to tell you that sometimes there are certain materials that when we lower down their temperature, they will not be converted into the superconducting state. હું તમને કહીશ કે exam છે, I'll tell you it is exam, you just go through, you read, you prepare, you write and prepare, but all of you will not do that. Some 5 or 6 students are there. But if I will tell you that I have kept an examination tomorrow, the number of students will increase for the preparation or not?
Yes, ma'am.
Yes,
છે
ma'am.
ને હું એમ કહીશ કે એક્ઝામ રાખી છે તો પેલા 5 જ જણ કરતા હશે એના બદલે કદાચ 30 કે 40 જણા પ્રિપરેશન કરવા માંડશે. So that is the pressure that I have created on you. Same way, there are certain materials that they normally do not get converted into the superconducting state. એ લોકો normally superconducting state માં convert નથી થતા. How much you take down that temperature, whether it is 4 Kelvin, 2 Kelvin, 1 Kelvin, they will not be converted into the superconducting state. But when you apply pressure on them and then you take down that temperature, they will be converting into the superconducting state. And very common example of this is cesium, that when you apply 110 kilobar pressure to the cesium,
Superconducting.
it will be converting into the superconducting state. If you do not apply pressure, how much temperature you will take down, it will not be converted. But if you apply pressure, it will be converting into the superconductor. So this pressure effect is generally used to convert the material into the superconducting state, if it is not. Fine, so that is the pressure effect. And as isotopic mass effect, Kreyo has shown. Kreyo, may I have that equation on the screen for the isotopic mass effect? Yes, this graph is also very nice, which you have shown that what happened for the isotopic mass with respect to the atomic mass, which you have shown that critical temperature, atomic mass, what changes occur. And I want its equation. Kreyo? T says
Yes, ma'am.
proportional to its equation. Probably it was in the first slide, equation of isotopic mass with respect to critical temperature. Tc is proportional to m raised to, here it is. Tc is proportional to m raised to minus half. Sometimes it is shown with the alpha also. These may be different materials, but as far as our syllabus is concerned, our materials are concerned, we have to take a value of alpha as a minus half. And there might be certain examples based on this equation. You may ask examples on this equation that Tc is proportional to m raised to minus half. So keep this equation in your note. If you have a fullscape and pen, just note it down in your fullscape. This equation is very important equation. And this equation shows that what happens to the critical temperature when the atomic mass will change, or for different isotopes, what will happen to the will happen to the TC, how critical temperature increases or decreases. Critical temperature increase થાય છે કે decrease થાય છે isotopic mass ની સાથે, and that is also presented in a very well manner here after the equation by Kreyo, that we can know that higher the isotopic mass, less will be the critical temperature, inversely proportional. Isotopic mass is more, critical temperature of that material will be less. As isotopic mass is less, critical temperature of that material will be. So which would be easy for us to use in a practically, with a higher TC or with a lower TC? What do we recommend?
Higher
Which
TC,
kind of this?
higher TC,
Higher.
higher TC.
Why higher TC?
કેમ કે ઈ ટેમ્પરેચર લઈ આવવું ઈઝી પડશે, એનાથી ઓછું કરવામાં જાજી પ્રોબ્લેમ પડશે.
Correct. So if I have to take the temperature down, that is tough for me. Temperature જેટલું 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 નીચું લેતા જવાનું હોય એ મારા માટે અઘરું છે, પણ temperature high રાખવું એ મારા માટે easy છે. Fine. So this is isotopic mass effect. In isotopic mass effect, you can write what do you mean by the isotopes. You can show this equation and you can write the relation that when isotopic mass increases, critical temperature decreases and vice versa. Fine. Kreyo, very nicely done, very nicely prepared, and even explained also very nicely that you have got the topic thoroughly and then you have explained it. Although you are not listening to you, but you have prepared your own topic very well. Is it?
Yes, ma'am. Thank you.
Okay, anyone else? Any other students?
કમ્યુનિકેશન મેમ બહુ ભારે છે.
Communication?
ભારે છે એમ કહે છે.
બહુ ભારે છે એવું
ના
છે?
સારું છે,
બરાબર.
સારું છે. ભારે એટલે મતલબ આમ,
હા, ખરેખર સરસ છે. હા, Kreyo, see what
Higher
he
level.
is telling. That communication is very nice, although he is from a different region and it is very difficult to communicate when you are your regional language is thoroughly different to other people, even if it is difficult to understand the pronunciation. But I think Kreyo is having a very good understanding to understand pronunciations of our English. So Kreyo, they all are telling that it's a very nice communication done from your side. And one thing that he has, he was ready to give a presentation without any force. That is also a very nice thing. He has taken an initiative. Students do not take initiative. That it's a difficult, we may not able to do, we may not able to understand, we may not able to explain. Instead of presenting, we enjoy over here in the hostel, staying in the hostel and playing football at evening. Kreyo, is that?
Yeah. Yes, ma'am.
Where do you stay? LD hostel?
That's all.
In which block you are?
I'm in block D, ma'am.
H.
You are in block D. Oh, somebody else is saying H. He is in D. I think probably another Eastern students are all in block D. So Kreyo, do you
Ma'am.
come on ground or not at evening? Cricket ground.
Yes, I come in the evening, ma'am.
Kreyo, you are not audible.
I go in the evening, ma'am.
You go in evening on a cricket ground?
Time, ma'am.
I do also go, but I haven't seen you.
Acha, I football, ma'am.
Okay, anyways, so it was very nicely done. Very nice, very good, Kreyo. Nice.
Thank you, ma'am.
Thank you so much to you all. So thank you. So who else is now?
મેમ મને
મેમ આ
doubt છે.
પ્રેશર અને રેઝિસ્ટન્સ નો રિલેશન આપણે ખબર છે કે પ્રેશર વધે તો રેઝિસ્ટન્સ ઘટે, પણ એનો કઈ પર્ટિક્યુલર રિલેશન છે જેમ કે ફોર્મ્યુલાની રીતે?
ડાયરેક્ટલી સુપરકન્ડક્ટર માટે આપેલું નથી, કારણ કે છે ને અલગ અલગ મટીરિયલ માટે અલગ અલગ રીતે બિહેવિયર એનું આવે છે, એટલે એવું ડાયરેક્ટ પ્રેશર અને રેઝિસ્ટન્સ નું નથી મળતું. બીકોઝ ડુ હેવ અ ડિફરન્ટ ક્રિસ્ટલ સ્ટ્રક્ચર. કોઈ મોનોક્લિનિક હોય, કોઈ ટેટ્રાગોનલ હોય, એટલે એ લોકો છે ને અલગ અલગ રીતે બિહેવ કરે, એટલે ડાયરેક્ટ રિલેશન નથી એનું.
ઓકે મેમ.
મેમ પ્રેશર જે આપણે અપ્લાય કરીએ એ મતલબ કે જો
જે આપણું ટેમ્પરેચર છે એકદમ લો છે એટલે સોલિડ સ્ટેટમાં હશે જે આપણું મટીરિયલ છે. તો સોલિડ સ્ટેટ પર પ્રેશર કમ્પ્રેસ તો થઈ નહીં શકે એટલે પ્રેશર અપ્લાય કરીએ તે કે પછી પ્રેશર અંદર જે મટીરિયલમાં છે એ અફેક્ટ કરે આને સુપર કન્ડક્ટિંગ સ્ટેટને.
I will tell you exactly how do they apply pressure. Let me check once so I can
Okay.
tell you clearly.
ઓકે.
If I do forget, just remind me. Next session આવે એટલે પહેલા મને પૂછજો કદાચ જો હું ભૂલી જાઉં તો.
હા મેમ.
અને હું પ્રેક્ટિકલ લઉં ને તો હું તમને વ્યવસ્થિત કહી શકું.